All right, so in this EdPuzzle, we are going to be going over the Chapter 8 study guide, so you have all of the answers down so you can be fully prepared and have an understanding of what you need to know for the test. So make sure to have your study guide out as you go through this EdPuzzle and be following along. So the first section asks to find the number of faces, edges, and vertices of the solid. All right, so for this, you gotta remember what a face is. A face is just one of the shapes as part of your solid. So this triangle would be a face. And when we're counting the number of faces on a solid, we would also include the base. So on this pyramid, we would include the base and the four lateral faces of the solid as well. So including all of these, you could count the number of faces. You have 4 triangles attached to the sides of your square, and you have your base. So the number of faces we have here is 5. 5 faces. Number of edges, so remember that edges are the segments that connect 2 different faces together. So this segment here, right, would be a face. This line segment here would also be a face. So counting number of faces, you have 4 faces on your square base, so that's 4. And then you have 4 edges connecting the triangles of your pyramid. So you have 1, 2, 3, 4, 5, 6, 7, 8 edges. So we put 8 edges there. All right, now the number of vertices on your solid. So you have 4 different, so your vertices are the places to where 3 different faces connect. So what I mean by that is, say this corner, you have the square base and 2 lateral faces meeting at this corner here. So every corner on this pyramid is a vertice. So all these vertices are where 3 different faces meet. So you have 4 connected to your square base, and then you have 1 at the top. And that makes 5 vertices. All right, so you have 5 vertices, 5 faces, 8 edges, 5 vertices for number 1. All right, so on number 2, same thing, we're identifying the faces, edges, and vertices. So number of faces on your, this would actually be a trapezoidal prism, is the term for this, is the term for this solid here. So the number of faces, you have 2 trapezoids as your bases, and you have 4 sides. So there's 4 rectangles attached to this prism along its side. So we can say that there are 1 to 2 bases, 4 rectangles means we have 6 faces on the solid. Number of edges, so we just have to count how many edges we have here. So on our 2 bases, we have 4 edges on each base. So there's 4 here, 8 on the other side, and then we have 4 edges connecting our 2 bases. So that means we have 12 edges here. Number of vertices, remember each corner where 3 different faces meet. So we have 4 on our top and 4 on our bottom. So that means we have 8 vertices. So that's how you identify faces, edges, and vertices of a solid. All right, so now let's try and draw out some nets. So number 3, it's asking us to draw the net of a triangular pyramid. Remember when I said a triangular pyramid, you start off with identifying your base. The base of your solid, your pyramid, is a triangle. So let's draw out our triangle. And remember, your base, every side always has a triangle coming off of it. So we can just draw out the triangles that are connected to our triangular pyramid. And that is the net of a triangular pyramid. All right, rectangular prism. So remember when I said rectangular prism, one of the best ways to set it up is you have the bottom in the middle of your net. So the bottom face here that the rectangular prism is sitting on will be the first one in your net. And then you have the sides coming off of it. This represents this back side here. So this would be your back side of your rectangular prism on your net. Then you have your right side and your left side. And then the top, remember, folds out down. So you have 2 rectangles in there because you have your side and your front side here. This is your front, and then this is your top. So your bottom is here, your top is here, and then everything else is folded out in that way. So triangular prism, same as rectangular prism, except we have triangles for our bases. So the way I set this up is remember, on a triangular prism, you have 3 sides, and you have 3 rectangles connecting your 2 bases. So I start off with 3 rectangles in the middle, and then 2 triangular bases I set in the middle of, attached to my middle rectangle on my net. So that is the net of a triangular prism. All right, now let's move on to using these nets to find surface area. So finding the surface area of the prism. So we have a rectangular prism that is 3 feet in width, 4 feet in length, and 5 feet in height. So to set this up, I think the best way to set this up, I'm going to put this here so I can draw the net on a separate sheet of paper. So we know the net of our rectangular prism starts off with, we have our bottom here, the back side of our rectangular prism here, and then we fold out the sides right here. Then the top, remember, I have the top, on my nets, I have the top fold out to the front. So folding this out, this is the top, and this is the front of my shape. So now I want to start by identifying the dimensions that are on the bottom of my rectangular prism. So I know that the width, or the length of it, is 4, and that's attached to this part of my bottom. And then the bottom edge here is 3. And then my height for all of these is 5. Now with these 3 dimensions, I can find all of the other different dimensions on my rectangular prism, because all these sides here are all related to the height. Because remember, the bottom and the top are going to be the same with 3 and 4. And then all these sides will involve my height. So I can add these numbers in light of that. So my height for these will be 5 and 5, because the height is 5, remember. So I have my length and width set up and my heights. So now I just have to calculate all the different areas of all these different shapes. So I'm going to start with the bottom. To find area, you use area equals length times width. So to find the area of a rectangle, 4 times 3 for my bottom is 12. So that's my bottom, and my top is also 12. And then, so bottom and top are going to be the same, because look on your rectangular prism, the bottom and the top are the same shape and the same size. On the rectangular prism, that's how it is. Bottom and top are the same. So these sides are also going to be the same, and these sides are also going to be the same. These sides here. So using area equals length times width, I can find that 5 times 4 here is 20. This is also 20. And then here, 5 times 3 is 15. And 5 times 3 up here is also 15. Because remember, all of these lengths are going to be the same on my net as well, because each is 3. And all of these are going to be 4. So now I just have to add them all together. I know 20 plus 20. All of my areas have been found. Now I just have to add all my areas together. So if I add them all together, plus 12 as well, equals, so we have 20 plus 20 is 40, plus 15 is 55, plus 15 is 70, so 70 plus 12 is 82. So the surface area of this rectangular prism, if I were to enter it in, is 82 square feet, just as we did on the net here. All right, now we are going to do the triangular prism. All right, so on your triangular prism, we're going to draw the net of the triangular prism. Remember, we start off on a triangular prism net. You have 3 rectangles attaching the 2 triangular bases. So I'm going to draw those first. Then I have my right triangles. These are going to be right triangles on this, attached to my middle side. And I'm going to put my right angles right here. Now when you want to identify the different dimensions of your net here, take a look at the base and the height. So the base of my triangle here is 3. Base here is 3. And my height is going to be 4. My base is 3, my height is 4. And same for this side. Base is 3, height is 4. And I fold it out. I have my edges of 5. My edge of 5 does not go there. That's my mistake. The edge of 5 goes along with my triangle right here. And then since this edge is connected to this rectangle here that's folding up, I can say that these two will be the same length. And this will also have a length of 4. So this is 5 and this is 5, just like this is 4 and this is 4. These two segments and these two segments will always be related on the net of your triangular prism. Now we just have to include the height of our prism, or the distance between the two bases, which is 7 centimeters, and that always goes along this part of our net. So now we can find the area. Remember, with triangles, we're doing something a little bit different. We're doing area equals base times height divided by 2. So we can find base times height divided by 2 to find our different areas of our triangles. So base is 3, height is 4, 3 times 4 is 12, divided by 2 is 6. And if this triangle is 6, this triangle is also 6. But on a triangular prism, these three rectangles will not be the same. We have to work these out individually. And we're using for a rectangle, area equals length times width again. So 7 times 5 is 35. 35, and then we have 7 times 3 is 21. 7 times 4 is 28. So now, if we add all of those together, 35 plus 21, 28, and I'm going to make this plus 12 because we have 2 6s to make 12. If I were to add all that together, I would get an answer of 96 square centimeters. So the answer to this one is 96 square centimeters. And that's how you find the surface area of a triangular prism. All right, number 8. A piece for a board game is shaped like a triangular prism. The piece is 18 millimeters long. The base of the piece is an equilateral triangle with 10 millimeter sides and a height of 9 millimeters. Find the surface area of the game piece. So this one is going to be a little bit more tricky in that we have to actually draw the shape ourselves. So the piece for a board game is shaped like a triangular prism. All right, so a triangular prism. Let's first draw a triangular prism. So we have our triangle. And we know if it's an equilateral triangle means that all the sides are going to be the same. Equilateral triangle with 10 millimeter sides, so they all have 10 sides to it. And then the piece is 18 millimeters long. So let's draw that. There we go. 9 millimeters long, or 18 millimeters long. And our triangle has a height of 9. Triangle has a height of 9. So this is actually going to be a little bit easier to solve than the other different triangular prisms because all our sides are the same. So we're going to draw our net real quick. Same thing, 3 rectangles, 2 triangles. Triangles have a height of 9 and 10 on all sides. And this makes solving this fairly straightforward because all of the sides of our rectangles are also 10 by 18. Length of 10, width of 18. So now we can solve this. So remember, to find a triangle, we do base times height divided by 2. 10 times 9 is 90. Divided by 2 is 45. So both our triangles have an area of 45. Now we just have to find all of our rectangles. 18 times 10 is 180, and since all the sides of the triangle are equal, that means we can say all of these are 180. So now, adding all of these together, we get an answer of 630. 630. And that would be square millimeters, because we're working with millimeters as our units. All right, so on the other side of your study guide, we are now dealing with finding the surface area of the pyramids. So remember, finding a surface area of a pyramid, and when we're doing this, we're assuming, according to the directions, that all the side lengths of the base triangle are equal. So that's going to help us in solving this. So we have a triangular pyramid to begin with. So remember, first off, we identify what our base is. The base of our triangular pyramid is a triangle. Well, triangular pyramids always have bases of triangles. So we have our triangle to start off with. And remember, no matter what pyramid you have triangles coming off of any side, all your sides. So now we just have to identify our base setup. So we have a base of 6. Our base here is 6 on our base triangle, and our height is right here on our base of 5.2 centimeters. So our height is 5.2. 5.2. And then now we just have to figure out how we want to set up our lateral faces of our pyramid. And the height of that is 8 centimeters. 8 centimeters. And since this is an equilateral triangle, we can determine that all of these triangles will have the same area, except for the base triangle. These 3 triangles will have the same area. The base triangle will not. And for this, we will only be using the formula area equals base times height divided by 2, because all of them are triangles. So first triangle is 6 times 5.2. So 6 times 5.2 divided by 2. And that'll give us an answer of 15.6. So we know that our base triangle is 15.6. And then our outer triangles are base times height divided by 2 again. So 6 times 8 is 48, divided by 2 is 24. So those are our outer triangles right here. These triangles are 24. So since we have 3 of them, we can multiply this by 3, and that'll give us 72. And we add these 2 numbers together. So 15.6 plus 72 gives us 87.6. So the answer to number 9 is 87.6 centimeters, square centimeters. That will be what we get. 87.6 centimeters squared. All right, next pyramid is a square pyramid. So we've identified our base. I'm actually going to draw this one right on our worksheet here. So we identified our base is a square, and we always have triangles coming off every side. All right, so our square is 5 feet on every side. So we can say that this is 5 feet, and our height of all of our triangles attached to our sides is 8, based on that. So easy to find the area of our square. Area equals length times width. 5 times 5 is 25. And then our triangles, 8 times 5 is 40, divided by 2 is 20. So all of these triangles are going to be 20. So now we just add all the areas together. 4 20s on our triangles, 20 plus 20, all these 20s together is 80, plus 25 will make 105 square feet. And that is what we do for surface area of pyramids. Volume of prisms. All right, so these ones are fairly straightforward. Remember, finding volumes of prisms, we just multiply all the numbers together. So let's just do 3 times 2 times 2.5. 3 times 2 times 2.5 equals 15. So the volume of this prism is 15 cubic meters. Remember, when we find volume, our label is going to be in cubic units. So if we have meters, it'll be cubic meters. And it'll be cubic millimeters here when we do this one. This one is 25 times 16 times 24. 25 times 16 times times 24 is 9,600 cubic millimeters. So that's the answer to number 12. Number 13. The rectangular prism has a volume of 936 cubic inches. Write and solve an equation to find the missing dimension of the prism. All right, so this goes back to what we learned in chapter 6, which was 2 chapters ago. So what we want to do is we want to set up our equation. So we know that our volume equation, volume equals length times width times height. And we know 3 things. We know our volume, 936. We know our length, 13, and we know our height of 8. We don't know our width. So our variable that we're going to have to leave behind is our width here. So volume is 936, and then our length, 13, times 8, and then we leave w to its side. So now we have to solve this equation. And so first off, we're going to do 13 times 8, because we're working, remember, to isolate w on its own side when we're solving these equations. So 13 times 8 is 104. 104w. 104w. So now that we have 104w, the way to get w alone on its own side is we apply the inverse operation of multiplication. Multiplication is being applied to w here. Inverse operation of multiplication is division. So what we'll do is we're going to divide 104. But whatever I do to one side, I have to do to the other side, the golden rule of equations. So divide both sides by 104. 936 divided by 104 is 9. So w equals 9. And that's my solution to number 13. Number 14. A playhouse is in the shape of a square pyramid with a side length of 6 feet and a slant height of 12 feet. The wood used to build the walls of the playhouse cost $3 per square foot. What is the cost of wood for the walls of the playhouse? So this right here is a multi-step equation. So what we're doing is we are going to figure out first the surface area of our square pyramid, because we are looking for just the walls. We're not looking for what's inside the playhouse. We're just looking for the walls, which means we're looking for the surface of our pyramid. So I'm going to draw out my square pyramid here. See if I can draw this out here. All right, so there's my square pyramid. And it has 6 feet at our base, our side length of 6 feet for our square, and a height of 12 feet. So now, in order to do this, we're going to draw out our net. We have 6 feet for our side length, and then every side has a triangle. Our height is 12. So for our square, we use a side length of 6 and multiply it by 6. Length times width, all the sides are the same on our square. 36 is our square. And then, now let's do our triangle. So 6 times 12, base times height divided by 2, is 72. 72 divided by 2 is also 36. So all of these are 36. Every part of it. So now we could just add all these together, but pay attention to the problem. We're not looking for the wood used to build the walls and the floor. The floor would be the square. The wood used to build the walls alone. So when we want to add these together to find just the walls, we don't want to factor in this square because this is part of the floor. So 36 plus 36 plus 36 plus 36, or 36 times 4, gives us 144. So we know that the surface area of our 4 lateral faces, or the lateral surface area of this square pyramid, is 144. We know the walls, the surface area of our walls. But we're looking for the cost of the wood. We're not looking for the area of it. We're looking for the cost of the wood, which is $3. So we multiply 144 by 3. 144 times 3 is 432. So the cost to build the walls of the playhouse is $432. All right, last question. To install the right size heating and cooling system, you must know how many cubic feet an office building contains. The building is 120 feet wide, 20 feet high, and 48 feet long. Find the volume. All right, so it's a volume problem. So you know, if you know the width, the height, and the length, you can multiply it together and find yourself the volume. So we are going to do 120 times 20 times 48 equals, what does that equal? 120 times 20 times 48 equals a big number, 115,200. And that is the volume of this office building. And that would be cubic feet. And that is your whole study guide right there. So use this to prepare for your test tomorrow.